Okay, so hello and welcome. Let's look at question 4.1, or rather question 4. It says that the sixth term is 243 and the third term is 72. They also give us the type of sequence. So if you go back to our videos, I think we've looked at this and we've said this is case number 2, and we said case number 2 questions require some involvement of simultaneous equations, right? So I'm just going to label this as question number 4. Number 4, it's given that the sequence is geometric. Right, and so that's observable. And with this geometric sequence, they tell us that T6, which I'm going to write over here, is equal to 243. Right? Now let me just give it some space. I'm going to say that's 243. And they tell us that T3, the third term, is equal to 72. Right? Okay, so I'm going to say, okay, these types of questions, we've seen many examples of them. We know that this is in sequences. We know that this is actually a case number 2 question, right, which involves simultaneous equations and using the general formula with it. So, okay, for geometric sequences, we know that Tn is equal to a, which is the first term, multiplied by r to the power of n minus 1. And so again, in this case, if we're talking about T6, this will be a r n minus 1, which is 6 minus 1 becomes 5, and this one will be a r to the power of 2. Okay, now I can simply divide T6 by T3, and that will give me the following, right? A divided by a, that's going, and r to the 5 divided by r to the 2 gives me r to the power of 3. And 243 divided by 72, let's see if we can use a calculator for that very quickly. 243 divided by 72, that gives me, 243 divided by 72, yeah, that's right, and that gives me 27 over 8. Okay, now that's something that's manageable. It's a cube, it's something we can actually work out. We can say to find r, we simply take the cube root of 27 over 8, and the cube root of 27 is 3, and the cube root of 8 is 2. So there's my r, right? Now, I actually jumped ahead, but that's what the question wanted from us. It wanted us to solve for the constant ratio. We can now take the constant ratio, plug it in here, and then solve for a, right? So this was the solution to 4.1 from here onwards. Okay, righto. Let's just see how we solve for a, which is not what the question wanted, but if it did, all we need to do now is we could say a times by r is going to be 3 over 2 to the power of 2 is equal to 72, and that's going to be 9 over 4. So all we need to do is we can take 72 divided by 9 over 4, and we get a solution of a being 32. Right, if you solve for that, that implies that a equals 32. Okay, righto, so let's look at question number 4.2.